Hi, everybody. This is the one I've been waiting for. This is multiplying two binomials. And a lot of people say, oh, FOIL, enough said. It's not, that's not enough. And I'm going to try to explain why it's so important that you go beyond the FOIL acronym and what the multiplication, what's really happening, how we use distribution method or tic-tac-toe method, or it doesn't matter the method. What matters is that you can undo it, that you can go and do it in reverse. And using the FOIL acronym will not allow you to do that. And going in reverse is called factoring. So I'm going to get to it. We'll start, of course, with the most familiar, which is FOIL, of course. And we're going to do that. But I'm also going to show you why we do it in other ways. So here it is. In order to multiply two polynomials, you need to make sure that you multiply everything times everything else. Every term has to be multiplied by every other term. And it doesn't matter how you do that, really, if all you want is the answer. Our ultimate goal is going to be able to take the answer and get the question. So we're looking to do the Jeopardy problem here. Anyway, let's get started. A plus 2 times 3a plus 3. And of course, we're going to use the most common one, which is I'm going to multiply the first term times the first term. That's the F part. And we multiply a times 3a, which is 3a squared. Then we're going to multiply the outer pair. The outer pair is the a times positive 3, which is plus 3a. And then we're going to multiply the inner pair, which is 2 times 3a. That's going to give us 6a. And then we're going to multiply the last pair. That's 2 times 3, which is 6. And the only pair that have common terms are the middle pair, which gives us 3a squared plus 9a plus 6. And we're done. That's how you multiply using the FOIL acronym. First, outer, all right, first, outer, inner, last. 3a. Trust me, this is not enough, okay? Plus my 9a in the middle, plus my last term, which is 6. We'll be doing this a lot, I have a feeling, so here it is. Okay, now this time, this is a special case, but we're going to go ahead and multiply it, and we'll go ahead and do the first, outer, inner, last. So first is z squared. The outer pair is going to be minus 4z. The inner pair is going to be plus 4z. And the last pair is going to be minus 16. This is first, outer, inner, last. And again, we can add the middle pair. You can always add the middle pair because they're going to give you the z's, or depends on I guess it depends on the situation. But anyway, if they have the same exponent, we can add them together. This does give us 0. It does not give you z, you get 0. And that leaves us with z squared minus 16. And this is a special case, and it actually has a name. This is called a difference of squares. Now I have some good news for you. One of the reasons that you want to learn how to multiply these is so that eventually you will be able to factor them. That means pull them into 2 equal parts, or 2 parts, not equal. In this particular case, if you ever get a difference of squares, like x squared minus 100, they will always be a very simple way of factoring them, because we know that the middle two have to cancel each other out. We know that the x times x gives us the x squared, and the minus 10 times positive 10 gives us the negative 100, and they do, the middle pair, do cancel out. Now, the reason I mention this is because a lot of times it's a good idea to look at where you're going when you're learning math. And where we're going is we don't just want to be able to put them together and get the z squared, in this case, minus 16. We actually want to be able to take the answer and get the question. So there it is. That's my justification. Anyway, I'm going to show you some other techniques for doing this. Now, a lot of people like the tic-tac-toe method. So basically what they're doing is they're saying, oh, well, I'm going to take x minus 2, and I'm going to take x plus 4, and I'm going to multiply the x times the x, which gives me x squared. I'm going to multiply the x times a negative 2 and get negative 2x. I'm going to multiply the 4 times the x. You can see this is a lot like a little multiplication table. And the 4 times the negative 2 is negative 8. And then they add the middle two terms, and they get their plus 2x. The first term, of course, is x squared, and the minus 8 at the end. Kind of silly, but there it is, tic-tac-toe. Lots of ways to go on these. Of course, first, in or out, or last is a very common type. FOIL, of course, works as well. The thing you want to keep in mind is that the whole point is that you're eventually going to want to be able to take it apart. The x times the x gives us the x squared. Our middle term comes from adding the negative 2x with the 4x. And notice that positive 4 plus negative 2 is positive 2x. And the last terms are minus 2 times positive 4, which is minus 8. Now this time what I'm going to do is I'm going to do something completely different. I'm going to show you that this is something very familiar. And the way I'm going to do it is I'm going to multiply 22 times 32. And at first glance, this doesn't seem to have much to do with what we're doing. Here's what I'm going to do. I'm going to say 20 plus 2 is really 22. And 30 plus 2 is really 32. But I'm going to multiply it using our standard technique. We call 2 times 2. We multiply it. This is called an algorithm. 2 times 2 is 4. And when we multiply the 2 times the 2, we're not really multiplying 2 times 2. We're multiplying 2 times 20, which is really 40. Now, we usually just simply write it down there, don't we? But we usually just put the 4 in the tens place and we just write it down. And a lot of people aren't even aware that this is really happening. Well, we usually put a 0 here, don't we, for our acronym, or for, not acronym, for our 3 times 30 times 2, is 60. This is our algorithm. And finally, I have 30 times 20. I'm not really multiplying 3 times 2. I'm multiplying 30 times 20, which is 600. And we add these together. And of course, we get the 4. And we have a 0 in the tens place, don't we? And we carried an extra 100. And we get 700. Which of course is 704. Now, why did I show that? Here's the reason. I just want to point out the reason that this is not something new. You see, this is very similar to multiplying 2x plus 2 times 3x plus 2. And when I multiply these two, I have plus 4. 2 times 2x is 4x. 3x times 2 is 6x. And 3x times 2x is 6x squared. In this particular case, the x is equal to 10, isn't it? And we end up with 6x squared plus 10x plus 4. And there's our trinomial. I just wanted to point out that basically I'm multiplying everything times everything else. I don't recommend using this technique on this type of problem because it's too easy. What we want to do, of course, is multiply the let's just go ahead and multiply them together. I have 6t squared. I have minus 6t minus 4t. I should probably put them in order, plus 4. Here's our 6t squared minus 10t plus 4. And there it is. Nothing like going off on a tangent. Sorry, guys. 6t squared minus 10t plus 4. I should have stuck with the easy stuff here. Maybe I'll redo it again. So we have first, outer, inner, last, or I'm going to show you a better method. Instead of trying to explain it, I'm just going to show it. Plus 2. I'm going to use what I call the stacking method, q minus 3. Now, if you were an elementary student in China, you would recognize this. I'm going to multiply the q times the 4q and get 4q squared. And I'm going to multiply the the 2 times the negative 3 and get the negative 6. To get my inner pair, I'm just going to cross multiply 2q and negative 12q. And I'm going to add these together. I'm going to get 4q squared minus 10q minus 6. You could still multiply them out in that long line. But what you're going to find is that it's a lot easier to get to see these when they're closer together, instead of seeing them separated, the 2q and the negative 12q way apart. In this particular case, they're written closer together, and it's a little easier to do it in your head, because ultimately the idea is to take it apart. Minus 10, oh darn it, minus, try again. I may have to put spaces, 10q, space minus 6. I may have to space this out. Maybe I'll try a little experiment and see if I can put them in closer together. The problem was that before, when I was multiplying my binomial times a monomial, it didn't allow me to leave with no space between the subtractions. So I had to put in the subtractions for that. Now I'm going to go ahead and stack this one. So I'm going to write the 2z. This is the one I should have used for my other example. Sorry about that. 2z plus 2 times 4z plus 2. And here's what I'm going to do. I'm going to multiply these, and I'm going to get 8z squared. I'm going to get 8z and 4z. Now I'm actually going to write them this time, but what I want you to notice is that it's pretty easy to put those together in your head. 8 and 4 makes 12z, doesn't it? And the last is the plus 4, the 2 times the 2. So this is going to be 8z squared plus 12z plus 4. I promise you are going to love this method for taking them apart. And I promise it's going to be so much easier in the long run. Ultimately, your goal should be to do these in your head anyway. Z squared plus 12z. And we have a plus 4 at the end. Okay, so this time I'm going to show you what I mean by doing them in your head. So we've got 3x plus 2, and I've got the 4x minus 4. Well, we know the first one is 12x squared. That's the first times the first. Now I'm going to do the middle pair in my head. 8x minus 12x. I'll bet you can do it. 8x minus 12x is minus 4x. If you're having trouble with your adding integers, it's really important that you learn how to do them. And the last step, of course, is 2 times negative 4, which is negative 8. Now, what I really did was I did the minus 12x and the plus 8x in my head. It is important that you do this in your head and that you write it down. Because if you can't, you're not going to be able to undo it. And I want you to be able to undo these. So we've got 12x squared minus 4x minus 8. I didn't put the space. Maybe that's enough. Yeah, I spaced it at the end instead of at the beginning. Hopefully it'll be good. Okay, so we've got. So this time what I want you to do is instead of writing it out, well, actually, you know what? I'm going to stack it one more time. 2m minus 1 times 3m plus 2. That is 6m squared, isn't it? 2m times 3m is 6m squared. Now I know you can take minus 3m plus 4m. 4m minus 3m is 1m. That's it, minus 2. It is really, truly that easy. 6m squared, we have a plus m, and we have a minus 2. I better put the space. All righty then. Let's see if you can do this one. Now, my recommendation is that you do more of these. My actual Christmas assignment for most of my Algebra 1 classes has always been to do 1,000 binomial multiplications, because that way, by the time you've done 1,000 of these, you'll be able to do them in your head instantly. It has to be that easy. It has to be, glance at it, 3x squared plus 2x minus 8. It has to be that easy, because you're going to be given this, 3x squared minus 2x minus 8, and you're going to have to take it apart into these. That's going to be ultimate goal. Right now, of course, you're saying, oh, well, I don't care about being able to take them apart. All I care about is that I get the right answer. Well, you need to be able to multiply these together. And I promise the best method is 3x minus 4, x plus 2, and look for patterns. X times 3 is 3x squared. Negative 4 times 2 is negative 8, and my middle term is 6x minus 4x, which is 2x. Okay? Nothing like making an error, dummy. Anyway, there it is. Prove my point that I can't do it right. 3x squared, talking too much, plus 2x minus 8. All right. 4n squared minus 6n minus 4. That's what you're looking for. To begin with, of course, it takes practice. 2n plus 1 times 2n minus 4. That is 4n squared. We have a minus 8n plus 2n. Negative 8 plus 2. See them? There's the negative 8. There's the plus 2. That is minus 6n. And then I have a 1 times a negative 4. I hope that's clear enough. I actually added the negative 8n plus the 2n and got the negative 6n. 4n squared minus 6n minus 4. Okay, yeah, I think we'll just do it. So 12g squared, 12g squared. Now, can you figure out what the middle term is? We've got a negative 3 times the 4, which is negative 12, and the -6, which makes -18, G. And then you have -3 times -2, which is +6. Let me erase this real quick. And I'm going to go ahead and write them out. 3G, oops, I said 3G, not 3Q. 3G minus 3, and we have a 4G minus 2, and we've got the 12G squared. I keep wanting to write a Q. Now, I have a minus 12 and a minus 6, which is minus 12G minus 6G, and then the last part is plus 6. Notice that that is a minus 18G. We're looking at ways in which to combine them. Hopefully that's clear. And we'll try it again. Now, can you do it in your head? Can you add the 12 and the 2 and get the 14? If you see it, that's important. It's really important that you see that combination. 2s plus 3, 4s plus 1. I have to write my s, it's kind of funky. That's 8s squared, isn't it? And the last is plus 3. It's that middle term that gives us the trouble, but that's just 2s and 12s, which is 14s. Hopefully got it. I may have to redo this one because I went off on a big tangent and I want to focus a little better. All right, so it looks like we've got 12k squared. Hopefully you can see. Plus 3, I find it easier to write them like this. 4k minus 2. That is 12k squared. I have a minus 6, and then I have to do the middle pair. That's 12k minus 6k, which is 6k. There we go. Okay. Can you do it yourself? I'll bet you can. 4v times 3v is 12v squared. Now my middle term, 3v minus 8v is minus 5v. I'm putting spaces just in case. And then I have 1 times -2 is minus 2. Okay, we'll stack them. Oh, I'm going to go ahead and see if I can make this clearer. I'm sorry I didn't do a very good job of it before. 42 times 34. This is the old, I keep wanting to call it acronym, but it's the algorithm that you go through. 4 times 2 is 8. And I'm going to write the 4z plus 2 and a 3z plus 4. And I'm just going to do them side by side. That's plus 8. Now this is 4 times 4z, which is 16z. And 4 times 4 is 16, isn't it? But it's actually 160. Now I want to put the plus 0. 3z times 2 is 6z. 3 times 2 is 60, or 30 times 2 rather is 60. And finally, 3z times 4z is 12z squared. And this, of course, is 30 times 40, which is 1200. Now, the thing is, we don't usually write it like this. We usually write it in like using our tens place and our hundreds place. But it's the same idea. This is going to be 8. In my tens place, I'm going to have a 2. I'm going to put an extra 200 into my hundreds place, and I get 14, don't I? 1428. This one is going to give us 8 plus the 22z plus the 12z squared. I just want you to notice that it is very similar to something that we've done before, that we're making sure we multiply everything times everything else. That is going to be, and I'm going to write it, I'm going to do it this way: 4z plus 2 and 3z plus 4. That's going to be my 12z squared. Oh, darn it. Z squared. There we go. 16 and 6 makes 22z plus 8. I just added the 16z and the 6z in my head. That gave me my 22z. Oh, try again. There it is. Plus 8. There we go. So now I made the connection, hopefully, for you. Definitely not going to do that again. So we've got our 8q squared. You know what? I'm just going to get rid of this. Just a minute here. There, I'll make it neat. So we've got our 8q squared. And for our middle term, we have 8 and 12, which is 20. Oh. There we go. Didn't want to go. Plus 20q. That's just 8 and 12 makes 20. And the last is plus 12. And we're done. That's it. That easy. Let's see. Could it be this easy? 8j squared. 4j times 2j is 8j squared. Now we got to do our middle pair. Negative 8j plus 16j is plus 8j, isn't it? You see, I have a minus 8 and a plus 16, and then I still have, I got to put my spaces, minus 16 for my lasts. Okay, I'll bet you we can do this one in your head. So you have 2c squared. Middle term, 8c minus c plus 7c, isn't it? Minus 4. And there you go. We're all set. We're getting there. Okay, so we've got a 4w. Shall I write it out? Why not? Let's write it one last time. 4w minus 1, w plus 2. That is 4w squared minus w plus 8w. That's plus 7w, just like the last time, minus 2. All I did was add the 8w minus, it's supposed to be a w, in my head, and got the 7w. We have 4w squared plus 7w minus the 2. Ooh, I think it'll be all right. Yeah. As long as you get the space in there somewhere so it doesn't think you're multiplying, I think you'll be all right. All right, so we're in the final ones. We've got an 8k squared. Notice I did multiply a 2k times 4k. Now I'm going to do my middle terms. I have minus 12 minus 8, which is minus 20. I'm going to put the space 20k. All I did was subtract 12k minus 8k, and then I have a plus 12. I'm done. That's all there is to it. Okay, we've got a 2x squared. And what I want you to do is I want you to think about the middle terms. We've got the 3x and the minus 6x, which is minus 3x, isn't it? And our last term is a minus 9. I'm spacing it all out so it works out nice. That's probably good enough. Let's maybe stack one last one. Shall we stack it? No, you can do this one. 2u squared. I multiply u times 2u, so 2u squared. I know you can do that. Now look, 8 and 4. Can you see them? I'm hoping you're beginning to see those. I have 4 times 2u for my inside terms. That's 8u plus my outer terms, which is 4u. That's 6. 8 and 4 is 12u. Oh, plus 12u, how about? And my last term is plus 16. Be careful. Right after you add, when you multiply, sometimes you add it by accident. So make sure you actually multiply those together. Okay, we have 8x squared. Remember, the ultimate goal is to be able to do this in reverse. So it's important that you do it in your head. Don't always write it down. In this one, you have a 2x and a 4x, which makes plus 6x, doesn't it? And the last is plus 1. Don't add those. We're multiplying. Okay, we've got a 6b squared. And then for our middle, we got a minus 2 and a minus 12. That's minus 14. And then we have a minus 1 times a minus 4, which is plus 4. Yeah, I think I'm going to end up doing this again. Darn it. Should have done it. Should have done it easier the first time. All right, so we've got a 2k squared. Our middle terms are plus 2, a minus 2k. That's 0. Our middle term ended up being a 0. And then we've got a 2 times negative 1, which is a minus 2, isn't it? I think I'm going to write this one out just so you can see it. Oh, dang it. Got a bunch of junk in there now. Minus 2. Doing it again. Come on now, stop that. There it is. Oh, I hit the submit instead of the space. All right, I was going to write that one out for you. No, well, that's okay. I wanted to do a few more anyway. So this is going to be 16w squared. 16w squared. We have a 12 and an 8, which is 20. Oh, it's doing it again. There we go. Plus 20w plus 6. Gets a little frustrating occasionally when your little boxes don't work. All right, shall we write it? No, this one's too easy. 4q squared. I know you can do it. 4q squared. All right, so we're in our middle term. We've got a minus 8 and a minus 4. That's a minus 12, and I spaced it out, q. And then we have a negative 2 times a negative 4, which is a positive 8. Okay, this is the one I like because look what we got. We have a 0 in our middle term. I meant to write this one out and then I didn't do it, so I'm going to write it out the first time. So we've got 2a plus 2, and we're multiplying that by 4a minus 4. And this doesn't look like a difference of squares, but what I want you to recognize is that we really have 2 times a plus 1, and this is 4 times a minus 1. You see, there's our difference of squares. That's the a squared minus 1. Anyway, here we go. 2a times 4a is 8a squared. Our middle terms are 8a and minus 8a. And our last terms are minus 8. Notice that gives us a 0 right there. So I get 8a squared minus 8. Notice that if I multiply these two, I get 8. And if I multiply these two, I get a squared plus a minus a is 0 minus 1. And distributing gives me my 8. I just want you to see some patterns and some things that are happening here, because we're going to need to do those soon. Squared, we have a minus 8. Want to recognize those when we see them. It's like I got 2 more. So I'm just going to write it in. I hope you'll do it with me. This is going to be 12b squared, isn't it? And then we've got a minus 12 plus 3. That's right. I know you can do it. Minus 9b. That's minus 12 plus 3 is minus 9. And then we have a minus 3. Looks like maybe 1 or 2 more. Oh, they gave us a nice easy one. We've got a 3t squared. We have a 12 minus 2. That's plus 10t. I know you can do this. And the last is minus 8, isn't it? And we have one last one. And don't just be content with mastery on this one. This one requires even more than, I don't know how many questions I did, maybe 33 or something. You're going to want to do some more. So practice this until you can absolutely glance at it and do it in your head. When you guys can say out loud, 8g squared. You see the plus 16 and the minus 6? That's plus 10g. You need to be able to see it. And the minus 12. Okay? It needs to be that easy. It needs to be 8g squared. The plus 10g in the middle. You need to be able to see it in your mind's eye. You don't want to just be able to write it down. You need to be able to do more than that. And the last step, the last part is minus 12, of course. I'm going to space it. All right, I hope you guys will practice a little bit, and I'm really looking forward to the factoring and the special cases, especially the squares, perfect square quadratics. You're going to like those, I think. So I will see you back again, and good luck. Get your mastery by, guys. Bye-bye. Oh, only 31. Not so bad. You can do this.